Okay, so just checking everyone sees just the PowerPoint, the big tree. All right. Okay, welcome everyone. This is a sharing session on building thinking classrooms. Welcome, Peter. Thanks for joining us today. I'm sure you'll be getting some questions your way. The format of these sharing sessions are really meant to be collaborative. I'm here to just share my own experiences and then hope to leave enough time and space later on for others to share theirs as well and to ask questions. I'm by no means an expert. I'm a practicing teacher who has been using this framework for the last few years. So just wanted Will reached out and asked if I would share specifically on how I address curricular outcomes. Okay, but before I start, it's really interesting seeing the number of people here and some familiar names and faces. I'm always interested in how people first get into the thinking classroom framework. That was part of our conversation before as people were coming in, especially now that the book is out. I'm meeting people who are reading about it through the book or coming to these sharing sessions in the middle of this pandemic where they're not quite able to fully try the framework out for themselves and still finding connections, still finding value in the reading. Because my own story is that I jumped right in, right? I went to a session with Peter and I experienced it first and then did all kind of the reading afterwards. I will say that once you experience it for yourself in full force, in person, up on the boards, you really will not turn back. So to elaborate on that story a bit, I first met Peter in 2015. We were just chatting about that. I met him just through a colleague, had a one-on-one conversation where he talked about his research, kind of sent me an article, and I read about it, piqued my interest. A few months later, went to a session with him. I remember sitting down, the session starts, and first thing he says is, everybody stand up. Gives us a card, we go to the wall, random groups, so everyone's a little bit confused, not sure what's going on, and he gives us a problem. I believe it was tax collector. Right? Some of you are familiar with, paychecks 1 to 12, and you take turns taking the factors. You take paychecks, and the tax collector takes the factors that are remaining. We engaged in that exercise. He was around, kind of not really saying much, but I remember I was dominating the conversation, and he walks over, takes my marker away, gives it to somebody else, doesn't say a word, and then walks away. I'm standing there confused, so I take the marker back. I continue to dominate. He comes back, still no words, takes it away again, smiles, and walks away. I get the message, and then I start talking more to my team members, and it's interesting experiencing that, right? I felt fully engaged, talking lots, thinking lots. We come back, and there's a buzz around the room, and we unpack it together, right? We say, okay, why did I do this? What did you notice about how I handled that situation? And it was really in reflection, right? That feeling of engagement, right? He asked the question, how long do you think we spent on that? Everyone's like, must have been 5 minutes, and it was 40, right? It was 40 minutes on tax collector. He walked around giving the next problem, like 1 to 24, 1 to 48, and then the general case. Some groups got there, but time just flew by, and that's what I mean in terms of that feeling of flow, right? Experiencing it for yourself, right? Seeing what it can be like is really powerful. So tonight's sharing session, really is to focus on using this framework to teach courses like grade 12 pre-cal, grade 11 applied, with very specific course outcome. How do we use this framework to address curriculum? Because it's fairly obvious how to use it to address problem solving, how to use it to address rich tasks, right? That's one of the key parts of the framework. But before I get into that topic of addressing curriculum, I wanted to really talk about, just briefly, a necessary condition in terms of setting the stage. at the beginning of every course, at the beginning of the school year in September, I spend pretty much exactly 2 weeks doing non-curricular thinking tasks. So I call this setting the stage. Really, it's quite intentionally just nothing specific. So things like tax collector, things like skyscrapers, and the reason I do that is to kind of set the classroom norms, right? It's instead of saying, these are the classroom expectations, kids experience thinking, problem solving, collaboration through activities that really intentionally draw that out. So 3 examples of kind of activities I use. You see on the right there, the tax collector. That's an activity that really helps them validate and justify their own thinking, right? When a group thinks they have the best solution for the checks to take, right? As the teacher, we walk around and we don't answer them when they say, is this right? Is this the best, right? But we ask back, how confident are you? And that just helps build their reasoning and justification of their own thinking, right? The answers aren't going to come from me, the teacher. They are going to come from the book. I really like the TED Ed problems like the Einstein's riddle and the Locker riddle and just different problem-solving tasks because it really emphasizes the logical reasoning, right? That math is quite logical and problem-solving that way. And then Skyscraper is probably my all-time favorite in terms of engagement because it actually requires collaboration, right? Physically requires different perspectives and points of view. You see 4 people sitting around a table looking at it from different angles, working together, quite a powerful thing. I've used it from kids at the grade 3 level to you see in the picture there, adult math teachers. So that's 2 weeks. That's not the topic for tonight, but I just wanted to make sure that I don't jump straight into curriculum because setting the stage is important to get that. It just so happens that 2 weeks is right around the amount of time that I need before the kids stop resisting the random groups as well, right? First day, they get the random cards. They're like, nope, I'm going to trade with this person. I'm going to push back. I'm going to, just kind of slide over to this group. And if you are just really diligent with making sure they're with their groups, letting them know that we are here to learn, all of us together, that learning and that information move around the room, then in all directions, then it really, they accept it. Then they learn to appreciate it. So that's setting the stage. And once everything's up and running, really kind of transitioning into curriculum feels pretty seamless. When the classroom norms are set, this is what it looks like on a daily basis, right? Kids barely use their desks. They just kind of throw their bags. They look for the groups, and they're up and they're talking. So when I present this framework and my own experiences at a variety of workshops, teachers, they see the value, but the question I get almost first every time is, this looks great. I think I'll use it for some problem solving, but I teach AP Calc or I teach grade 12 pre-cal, and it's not going to work for that, right? There's too much content. There's too many outcomes. And really, they're concerned. I think I hear the biggest concern is, what about things like logarithms? How are they going to discover that when they don't know what it is, right? So how do you unpack that? So the short answer is there is a way, right? There is a way to teach an entire course in this framework, right? You don't have to have a mix of, okay, let's sit and do a regular direct instruction for Monday to Thursday and then do thinking classrooms on Friday, right? This is every day of my course. Not every day, but a big part of it. Other days are for consolidating mindful notes, that kind of thing, okay? What usually wins them over, because the concerns around not being able to teach new concepts is also tied to the concern of not having enough time. So an activity that I started doing in workshops, and Peter introduced this one as well, is what would Gauss do? And this one really wins them over because they see that some really big ideas can be learned faster than if they were to teach it in a more traditional way, right? Like Peter in a session asked, how many days do you spend on arithmetic geometric sequences and series? Teachers will say anywhere from 6 to 10, right? it's chapter 6.1, then 6.2, and they step it out that way. Whereas the activity itself, I won't go into the details. We can kind of write it up and chat about it later, but really has an anchor, which is a story, right? What Gauss does as a strategy, and just slowly builds on that one change at a time, right? How do you sum 1 to 100? How do you sum 1 to 63? How do you sum 13 to 63? How do you sum 13 to 63 odd numbers only? How do you sum 13 to 63 every third number, and so on? And different pockets along the way, you stop and to generalize, right? Instead of 1 to 63, what about m to n, that kind of thing. So that's kind of a strategy called thin slicing that we are going to dive a little bit deeper into tonight. But what would Gauss do as an activity is the one that normally convinces teachers that it's possible, right? That new curricular outcomes can be learned in this framework, and it'll actually save time. And so that newfound time can be spent consolidating, practicing, and solving new problems. So thin slicing is one strategy. It's not every. I would say I have three main strategies in the building thinking classroom framework to teach curricular outcomes. So thin slicing is one that I'll get into in further detail later. Desmos is another one, and then Smudged Math is one that I like a lot as well. So very briefly, Desmos. There are a wealth of activities, resources, but I'm not going to talk about all of that today. Just very simply, one of the most powerful things that I think Desmos does is just the animations, right? Like the power of technology comes in when it does things that you just can't do on pen and paper, right? Transformations, playing an animation of one, right, is just in real time is different than trying to draw how, adding to the B value might change, right? Like you can't, seeing it in real time is one thing. For example, I'm just going to shift over to this. Can everyone see the Desmos screen? Yep. So unit circle and trig functions. Quite honestly, I play this, and they've never seen it before. Play this for 5 minutes. Have some nice music playing in the background, and I just ask them to write everything that they can notice about the animation they see. That's an example of just introducing something new, giving them the time to just really unpack it, right? And then talk about it, right? And then maybe get up and just write as much as they know, questions they still have. So that's an example of how I use Desmos. There are many others. Smudged Math is another interesting one. If you are not familiar, really it is taking some equations, pictures, graphs, and just blocking out parts of it, right? And getting the kids to figure out what's underneath the smudge. It's more powerful than just assigning variables. Like it's more than just because you can block out like huge chunks of a picture or huge chunks of an equation, and it's treated like a puzzle, right? Kids see that, hey, this is something I can figure out. The picture you see on the right there is the very first time they've seen the log notation. They have no idea what a log is, right? So you have an anchor as in, so the story is, I can tell you what a log is. Here's some exponents on one side, and there's this new thing on the right, but, my 6-year-old spilled her slime all over it, right? It's interesting when you frame things as a story, how believable it becomes when you show them that, hey, it was just you, like with a marker smudging it out. You hear the groans, and then they catch on, but they still do enjoy the puzzle. This is an example of smudged math for synthetic division, right? Polynomial long division, we learned that, and then when the new idea of synthetic division, I don't explain it, I don't even show what it looks like. I say, hey, here's a picture of this thing that kind of corresponds with long division, which we know, right? That's the anchor. Here's how it works, but again, somebody smudged it all out. Can you help me figure out what's going on? And within a 60-minute class, they figure out what synthetic division is, how to do it. because they pieced it together themselves. And you know, as Peter says, when kids are engaged, like, you'd be surprised how easy everything else becomes. You don't have to explain every little thing. They hear it from each other. They figure it out for themselves. They make notes to themselves, and it really moves along quite quickly.
Quick question, Lam.
Yep.
On that slide you have there, I assume your students are familiar with polynomial long division here.
Correct. So that would be a different learning experience. This lesson was synthetic division. If you're wondering what I use to teach polynomial division, it's exploding dots. Are you guys familiar with the exploding dots?
That's a good one.
Yeah. So that starts at junior school, like grade. I've done exploding dots for number systems at grade 2, grade 3, when they're learning place value. But as it becomes generalized, it works just as well for polynomials. So yeah, that's another conversation. Be happy to kind of follow up by email if anyone is interested. Okay, so the example I want to dive into thin slice. So those are two just kind of to mention. Thin slicing is a powerful one. Thin slicing is one that I use quite often. The way I frame it, and I apologize, I'm not following the chat. If there's questions, I'm not trying to ignore them. We can kind of get back to them later, or I'm sure there's other people answering as well. But flow or engagement, right? In problem solving, like the tax collector, you give the problem 1 to 12 checks, and you let groups engage with it, right? They're talking, they're figuring it out. It usually takes, it's a variety, but it usually takes at least 5 to 10 minutes for a group to solve, right? So it gives the teacher time to just look around. Thin slicing, the thin refers to how big of a step the next part of the problem is, right? So by thin, it's just a smaller step. So the teacher is more engaged in walking around and giving the next step, the next iteration of that problem. So it does take kind of more energy from the teacher, but it allows to kind of keep a closer eye on that flow, and just kind of, I don't want to use the word control, but just navigate that learning experience a little bit tighter. And that's why it's useful for curricular outcomes. So the way I frame it is, I don't know if you heard Dan Meyer talk about mathematical surprise a lot, right? When there's a new formula or a new theorem or a new concept to learn, right? I always frame it to kids as, at some point, right? This formula or this idea was surprising to somebody, right? Some mathematician who discovered it for the first time, or in many cases devoted their life's work to figuring it out. It was surprising to someone. So I'm not going to give it away, right? I can't just spoil the movie for you, right? I can't spoil all of that thinking. So we're going to figure it out ourselves. But with every surprise, they need some kind of investment, right? So it can't just be me telling them how the person discovered it. They need to, care about what they're doing. This is one of my favorites, right? And this is the investment. So the quadratic formula is one of my favorites to do with thin slicing. So the reason is, when it's introduced, it's already been spoiled, right? When I show this and I say, how would you find where the parabola crosses the x-axis, or what x values make f of x 0, probably 1/3 of the class have heard of the quadratic formula, either from a physics class or just from outside, and they say it, right? They plug it in, they say the answer, and when we explore where it comes from or how they know that works, right, they're not quite sure. The rest of the kids haven't heard of it and are completely lost. So again, with that different starting experience, how do we kind of level that experience and go a little bit deeper? We derive it ourselves. And I'm not telling them that we're deriving it. We don't actually start with this problem. The lesson for the day is anchored in just solving equations, right? So this is an example of one lesson, right? These are my own notes, problems I would put on the whiteboard. So you can tell it's pretty thin because that's going to be solved in about 5 seconds, right? The 3x equals -5. The idea, okay, we just need to get x by itself. I'm done. So I give them the next one. like that. And paying special attention to one of the benefits of thin slicing is they notice the difference, right? What changed between this question and the last, right? Just navigating a little bit more of the algebra to isolate that x, and then, what's different about this? Okay, there was a zero on the side, there's a negative, and so on. The nice part about thin slicing as I go through this is, if a group is still not quite sure, we don't have to add that change, right? We can kind of take a step sideways and give a second question that is similar, right? To give them a little bit more practice, you have that autonomy to really navigate that. If you kind of foresee that this would be just too hard to walk around the room, kind of giving everyone a new problem, right? Because we've set the stage that they're used to looking around, really, and they're also used to making autonomous decisions. They'll just look around for the next problem, and they'll just kind of try it on their own as well. So it does move forward. Here's a sideways step. Just like the Gauss problem, where there's pockets where we pause, go a little bit deeper into generalizing, right? 2x plus 18 equals 0. Can you do that in your head? Yeah. What are you doing? That 18 becomes a negative. Divide by whatever's in front of the x, right? What about 3x plus minus 15 equals 0, right? What's happening in your mind? And they realize that, oh, if I put it in this form, I've just generalized a formula for linear equations, right? If I move things so that there's an x, there's a constant, and there's a 0, I can just quickly see what the solution is going to be, right? That gets them, it's kind of like foreshadowing in a movie so that they're going to have a similar experience later. So the next step in this thin slice, so they've done 2x plus 18, they've generalized it. Okay, how is this one different? So you notice that this is a pretty big step, right? It introduces a concept that is a pretty big change from just a linear equation. So when I give that, I'm a little bit more observant on who is having a hard time, so that you can come and you can ask some questions, support right away. Yet the biggest change is now there's two answers, right? There's just not one answer to x. There are two values that can make that true. Not a very big step, right? You'll see that some kids who know about factoring might jump to factoring, right? That's fine. That's fine for them to explore that. I like to guide them back to, let's stick to what we're doing, just to stick to a line of thinking. Can we isolate x, right? Can we move the 9 over square root? Can we get x by itself? You see two answers. Kind of a sideways step, just a few changes there. Okay, a little bit different, right? So a little bit different, but still the driving question is, can we get x by itself? Square root adding afterwards. Can we get x by itself? Pretty important side step there, right? When they try to square root, which they've been used to for the last few questions, they encounter a problem. So it's nice to draw that idea out. And then you keep going, right? You keep going, okay, kind of fairly similar. We're not going to do all the math here, but you notice that we can get x by itself. Okay, so if I move the 1 over, I have 24, or what can I do? Like, there's a problem with this one, right? But how can I make this one similar to the previous? Can I factor it out with a binomial being squared? Not all. Sometimes I can, but not always. So that's a huge jump. But the idea of completing the square, believe me, is attainable through conversation, right? Oh, I want that perfect square because that x minus 3 one, this step right here, it was perfect, right? They could have just square rooted. When they notice that that's what they want to do, completing the square, right? It's kind of they're motivated to find that. So it comes fairly naturally. I've seen it happen from scratch, and they continue doing that. Things that make it harder, completing the square, right? That leading coefficient, and eventually they have some practice completing the square, and then you go to the general, right? And the question is simple. Let's get x by itself, right? So the moment that, and they're into it, right? They're doing it the moment that they realize, as they're writing, you see it, as they're writing and x equals, and they start realizing and simplifying the fraction, noticing that it's actually the quadratic formula. The kids who were familiar with it but didn't know where it came from, it's amazing, right? It is the exact same reaction as Darth Vader saying that he's Luke's father. Like, I promise you, I've seen it. I know, I'll come back to this. I know, Judy, you used this as well in a presentation, right? The face that they show when they discover themselves is priceless. So to unpack thin slicing a little bit and the power of it, right? I look at this, I can give this sheet, I have given this sheet, this string of questions to people, and it looks like a textbook, right? The power of it is really understanding as the teacher that not every step is equal, right? Where are the big jumps? Like I would say, those are all small jumps. These together, right, from the blue to the green, was a big jump. When kids are looking at a textbook, it all looks the same, right? So they don't know when to kind of slow down and really think deeply. And when you put the thinking on the walls and make it so visible, it helps you support and ask questions when they encounter those big jumps, and just kind of those side steps as well for practice. And really, again, that was all done 60 minutes. So learned completing the square in a 1 hour lesson, as well as deriving the quadratic formula. And now knowing where it comes from, using it is no problem. And it's interesting, even after this lesson, I did this for the first time a couple years ago. From that point on, kids loved completing the square. They actually prefer that over plugging it into the formula. They would just do it and then solve it that way. And it was interesting to see, because prior to that, a lot of kids avoided it, right? Because they didn't quite get why they're doing that. Things like this, right? I put this as something that really bothers me, and I try to stay positive, but I see a lot of memory tricks. If you haven't seen this, it's a way of remembering the quadratic formula. A bad boy is a negative b. He's being unsure of the plus or minus. Like, it's cute, yes. It's funny, but every step that we take towards math being just things to remember coming from an external source is a step away from sense making. Like, I don't see a middle ground, right? It's not like I can make sense of it and I'm going to use this to try to remember. The more that kids feel they are owning the learning, it's just a positive step. And this applies to, unfortunately, I get the positive energy around like acronyms and songs around trying to remember things and just tricks like that. Like, I get it. It makes it fun on the surface, but I see kind of a real danger lurking in terms of how kids view math and how kids view themselves as learning.
Hey, Lam.
Yep.
I am totally not afraid to interrupt. I hope that's okay.
Of course.
All right. So, if students have made sense of completing the square and that was a very organic experience for them, which is totally a good thing. Once that's happened for them and you feel comfortable and they're having reasoned their way through it, how does that change the questions downstream for you that they might see where that becomes applicable? Because the mnemonics, I feel like, are really about trying to get it to stick in their head. I'm not big on mnemonics myself, but I know why teachers use them. They want to get that into the memory so that's something they can always recall. But I always feel, for me, it's like, if I've seen the evidence that they've reasoned their way through it, I'm not particularly interested in the mnemonic. I'm happy to have them look that part up. But if I change the question I asked where that becomes a necessary tool later, they will quickly come back to that item, even if they couldn't get it right off the top of their head. Does that happen for you at all? Or how do you have them use completing the square later then?
Oh, you mean like in what context? Like what types of problems?
Yeah, like, you can ask them to complete the square after they've reasoned their way through it, and they should be able to do it right away. And I get retention takes a lot of retrieval and all that kind of stuff. How much of it becomes the mechanics then, and how much do you hold them accountable to having right quick if they're ready?
So I would say, like, they were using it to solve an actual problem, right, in a context. Like in terms of just solving quadratics without context, like, I don't do that a lot. Like, I use a lot of technology, so especially Desmos, like they kind of think it's funny that they would need to do it by hand when it's at their fingertips. So I mean, that's I think a different conversation, but in terms of just the skill of doing it manually, it isn't really there. But because they understand everything that's going on, like just being flexible with that and problems that they've never seen, I found just more traction, more success.
Awesome, thanks.
So actually, that was the last slide. So I stopped sharing. I'm not sure if there's a question. I'm going to scroll through kind of some of the comments here. But if anyone else has a question, I'd be happy to share or try to answer. And also anyone else who'd like to answer, like I'm really opening it up at this point.
So I'm just going to look through the comments real quick and make sure nothing was missed.
So we are all here to learn together. Very important, right? And that's other parts of the framework. Helping them ask each other, right? The teacher isn't there to give all the answers. What would Gauss do? I love that.
Michael Rubin and Adina have started asking questions at the bottom.
Okay.
That look to be pretty good.
Sure. So how do you know you've given them enough info to get started? So that, in terms of the planning process, really one new concept per lesson, right? Like I'm not trying to like teach 5 different things and then what anchor goes with that. So logarithms, for example, the anchor is exponents, right? So what enough info is just really something to think about. And really you don't even need everyone in the room to have that anchor. If you're in random groups, you need about 25% of the room to have it, and then it just bounces around from there. So Garrett, how do you approach writing these thin slices? To be honest, textbooks are a good start. Textbooks get kind of a bad rap in terms of how they present problems, but that's a lot of work in terms of how the progression of ideas are thought about, right? It's just the framework helps present that so that the kids are owning it, and you can help highlight through experience what's important, not just what's in the textbooks. I think one of the drawbacks is that it kind of highlights everything that's important for you, right? Which is good to look back on, but as you're learning something new, you kind of discover that for yourself. So thin slicing gears towards skill building. So I wouldn't say so. It's a new concept that I approach, but skills as well, I suppose. Does anyone else have ideas around that?
I think I would add that it definitely can be helpful at building skill, but the difference between showing them the technique and having them copy it and using thin slicing is the skills themselves become just simply the tool they need to figure out or learn, because they're actually asking a bigger question about the concept. What are we trying to do? Oh yeah, I need to do this maneuver, and that becomes a technical skill. And then as you go through the sequence of questions, the skills kind of just naturally compound into a package. Others might disagree, but I think this is a good segue into Michael's question, which I think got missed at the top there. How do you approach writing thin slices? You addressed that a little bit, I think, with the fact that textbooks already do a fair amount of listing questions in a pretty good progression, but I'll let you take it from there.
I'm not sure. You think of the new concept and you think of an anchor, and often I actually think of the easiest anchor possible, just to make sure everyone gets a nice kind of accessible entry point, and then just make sure every step is different in an important way. It takes work, but to me that's really part of the fun work, and then seeing it come to life is just kind of sitting back and watching the show.
And I can remember when I was reading Peter's book, he has an example of thin slicing. So someone said, where might I look? Garrett, there is a part in the book where it talks about thin slicing. And I'm always mad because I had made my own before I'd even heard the term thin slicing, and I had my students working at boards, you kind of naturally find your way into this. Well, what's a good place for students to start? And I can remember my lesson was on multiplying polynomials, but you have so many after you do that, after you set that up the first time, and then your students, you have those couple of groups who are just making complete sense of it. And the next thing you want to ask them is, ooh, I wonder if they can do this in reverse. So you set up the trinomial and you say, find me the two binomials that multiply to get this. And suddenly they find themselves in a factoring really intuitively, especially if they've seen something like the box method or area model or whatever. And so the next time I set that up, I had already listed out, well, I mean, I had half my class get through factoring on the day we were talking about multiplying polynomials, because it becomes such a natural flow. And so how do you start it? You just try it and you get better. You learn just like they do after the first time. But I do think that does open up another really, a kind of a place I'm in about this, which is I want to get pretty formal about what are the topics, what is the natural sequence of topics, what's a good place to start on a thin slice, where's the minimum I want to get my students to, and then I'll use Flow to manage them there, and I'll have extensions for students who are ready to go beyond that, and so on. But I'd like to have some kind of established sequence ready for those types of things, so I'm not trying to make it up the day before.
Yeah, for sure. Oh, for sure. Yeah, this is not something to kind of make up. Like the side steps you can make up, it's just changing the numbers, but the important steps to move it forward, it's important to plan. Just Will, your example about factoring reminds me that's another key kind of prime concept for thin slicing, and just again exactly at the same time as the multiplication and bringing visuals into it helps as well in terms of the area model. And it's interesting because factoring polynomials, I would say a lot of teachers identify as something that kids have a hard time with, and you do these different types and then these different strategies for the different types of polynomials, and they just kind of compartmentalize everything where it's naturally so connected to multiplying. So I saw a question about struggle though. I just don't want to. So Bonnie asks if you see students struggling, or a majority of students, how do you handle that? So Bonnie, can you say a little bit more about what that struggling might look like?
So I hope you don't mind I unmuted. I thought it was easier than typing it.
Of course, yeah. No.
I'm not a texter. So I saw Jessica, I'm trying to read and kind of, what I've encountered with my student population, and because of the mindset, I think somebody had mentioned this at the beginning, forgive me, I don't remember, because almost entirely teachers, math teachers at middle high school level are lecture based. In direct instruction. So then when they come to me, they're like, they're not happy, to say the least. They think I don't know how to teach. And then they go complain and all that stuff. So they're very resistant and reluctant. Getting them to go up to the board is like pulling teeth. But I don't give up easily. But when I get to the point where, okay, they're up at the board, they're at least at some level of collaboration. And you had mentioned this at the beginning when if one student is overtaking and I'm trying to intercede, but it's still the other students aren't engaging, I don't know how to get the other students that are more quiet and reserved, or just, I don't like this, I don't want to do this for whatever reason. I don't know how to get them there. And that's been my biggest struggle, where I always have a certain number of students in my class that are like that, no matter what I'm trying, but sometimes a majority, depending on the student. And I just wanted to kind of see what you would do. Thank you.
Yeah. So two things that you shared that kind of resonated with me right away. The first is I teach 9 to 12, and sometimes I'll get a grade 12 class who have experienced education K to 11 in what you would call lecture based, right? And you're right, a small handful of kids are not happy. Every single year that starts in the grade 12 section, I guarantee there's at least a couple kids who actually try to switch out of my class, right? They say, I don't learn this way. I'm an introvert. I like to take notes. Where are your notes? And, and even to extend that conversation, I've had parent conversations too. Why don't you have notes? Why aren't you teaching? right? So a couple things I do for the parents and the kids. For the parents, first of all, I invite them into the space, right? This is to help them understand this is what we're doing. And usually that day I'll leave the thinking up on the whiteboards and say, you know, the kids are getting used to creating, getting used to valuing their own ideas, right? I'm here, like, don't trust me, I'm teaching. I'm here to help them navigate that. They will arrive at a place that is better learning in math, and to put it. Um, and the kids, some of them kind of move a little in terms of winning them over. And to be honest, by the end of the year, not everyone, right? Like really, some still don't enjoy it. It's the number's fairly small. What I do in that year is, you know, show that they can make some autonomous decisions. If a group member is, you know, having a hard time finding a voice, right? Like one strategy is give them the marker, let them listen for a while and write things down, right? Hold the whole group accountable to make sure everyone kind of understands. So for the quadratic, that step x squared equals 9. Yeah, some people don't know to square root both sides. Some people don't know that kind of leads to two answers. Have kids explain to each other, right? Hearing it from a classmate is more powerful than reading it, or more powerful than hearing it from the teacher. If it's wrong, to kids, like people, and so I've had teachers come to me and say, you know, if you let kids talk too much, they'll teach each other wrong things, and that's a real danger. And it's interesting because I say, you know, if you have two kids debating about math, that's pretty much a guaranteed win, right? Because they'll realize they're wrong, right? Like you can't be wrong and then stick to it, and then right, and being proven that you're wrong by your classmates through logic is way better than just finding out you had the wrong answer, right? Or you messed up the equation. So there's that. Just trying to navigate those conversations. But again, some kids kind of pull back or shy. Let them walk around the room. Just take a look at what other groups are doing, right? Give them that freedom to make decisions that help them, right? And two things, like it helps them reflect as a learner. Why am I having a hard time with this? What do I need? And that's just kind of really positive moves, I would say. I'm kind of lost in the comments here. Peter says, "Be over prepared." Yeah, so constantly surprised by how far people get. Someone, Jessica, you're teaching your own daughter. My daughter's in grade 12 as well at home, and she doesn't appreciate my expertise as much as my students do. That's for sure. Nicholas, I saw a comment on. Nice to see you. I have a group of my BEd students here. I'm not sure if they're making me more nervous or less, but it's nice to see you, GF. I see you. But right, even permutations, right? Like counting. It's so fascinating that people think you learn how to count by grade 1, where counting really is a university level concept, right? So from K to like your PhD in counting, it's all there. And when you think of differentiation, planning for that is becomes easy when the concept stretches so much, right? So that's when I first introduce this. That's one of the biggest questions that I get, right? How do I handle differentiation? And that's kind of the underlying concern that Peter mentioned about random groups. So there's lots to say about that, but the random groups and kind of the planning, the work you put ahead, kind of makes things accessible and also has that extension. I don't know if this is applicable, but how much room is there for personality? Oh, off task behavior. Michael, do you want to say a little bit more about what you mean before we share about that?
Yeah, so I was trying this a little bit in some classes with that were designated for students learning English, and I was finding like it was really hard, even on rich tasks, to keep some of them on task. Like some were like going to their friends, they were like playing tic-tac-toe, and I was like, I just don't know what to do about that. So
I guess the first thing is my goal in the class is to create that engagement, that flow. So if I've created, I'm certainly not going to disrupt it or allow an individual to disrupt. So I definitely don't stop the whole class, right? I don't draw attention to it. I try to find out what it is that's causing them to be kind of off task. Like, is it not accessible, or when we say, is it not interesting? That's something to reflect on, because in the planning, right? Like, you really put it to the test. Like, I'm not giving like so many different activities that I'm careless with them. Like, every single activity, and as you do it for years, you realize and you tweak to every activity being pretty engaging. Right? Skyscrapers, for example, like, I really don't believe that people wouldn't find that interesting. Like, just our natural tendency to want to solve problems, to want to kind of work together, is pretty powerful. But even then, there are going to be kids who choose to play tic-tac-toe instead, and I'm not sure. I mean, I nudge them. I nudge them back. I try to show them that they bring value to the group. But does anyone else want to share any strategies there?
I'm curious how long you've had those students trying to operate in this dynamic. Is this pretty new for them still, or is this something you've been trying for some time, Michael?
I was trying it with rich tasks with not a whole lot of experience, and I'll be honest, I gave up within about 2 weeks when I transferred to curricular tasks, because I was trying to teach the curricular tasks through rich tasks, and it was a disaster. I wasn't able to make it work, and so I stopped doing the vertical surfaces and I went to group work. What was interesting with the groups is I was trying to do the thin slicing, so it's keeping the format of the problems the same. And even though not all students were engaging, they would just naturally get up and go check others' work, and I was afraid they were copying. But when I checked, they were actually explaining. Like, they weren't explaining in English, but I could tell it wasn't just what's the answer. It was explaining it out. And I never tried going back to the whiteboards, which I want to do again, because I think that might work better. But I had not had a lot of experience when I did this, and I'm pretty sure I did a terrible job of managing flow. So I think maybe it was more of an issue of managing those hints and extensions.
Well, don't be too hard on yourself. It's new territory for students and teachers a lot of the times too. So.
Yeah, just reading this comment on thinking is hard, but it is helping me. I mean, it's so powerful that kids are reflecting on that. I had two kids come to ask me a question. One of them asked, "Hey, Mr. Nguyen, how do you do this?" And the other one just looked at him and said, "He's not going to answer that, right?" And it's so annoying, but it helps. So they know that it's annoying, but they know that it's best for their learning, right? Kids, you trust them, you want them to own the learning, but they don't always make the best choices for their learning, right? If you let them make groups, they choose their friends. That's just natural. So the framework really helps in terms of the random groups and the questioning to bring learning to the forefront.
Just back to Michael's dilemma here, I just want to share an experience from a couple different classes I was in. One of them, like, I was observing students, but I wasn't the teacher. And so I think this gives a different perspective in observing the off-task behavior, weaving into on-task behavior. So, like, there's one example of a student who was just goofing off, doing nothing, and he was paired with these other students that didn't want to do anything either. It was just in one group, but at some point he was like flicking his pen or something, and then his gaze landed on something else on another whiteboard, and he like stopped, said, "Oh," and then he went to the board and started writing. And it was just so cool to see how there was no teacher intervention, but the mobility of the knowledge around the room can sometimes really trigger that. And another case was, I was trying it out with a teacher who had just started doing this as well. And we were all observing the class in different places, and everybody noticed that several of the students would go on task, off task, on task, off task. And it depends on how you're managing flow, of course, but I'll say like you almost have to like trust it that even if you're not managing flow perfectly, like there's still variance in the on task and off task. So I don't know if that helps, but I encourage you to try more, but yeah. I think Al has some strategies for this as well, but I don't know if he's here.
I am here.
You are here, yay! Sorry. I didn't want to tell your story. Oh, we can't hear you very well.
The audio's a little.
Off-task behavior, like I'm pretty. Can't hear me?
No, can't hear you very well.
No idea why. That's too bad. Let me see. Okay, I'm going to bye.
A little bit better. I think, yeah, I think he was going to say something about I'm pretty relaxed about their behavior. That's what I thought he was going to say, but I don't know.
Yeah, Jessica's talking about, you know, making sure that everyone feeling that they can contribute, right?
Mm-hmm.
So maybe I can jump in on this, not
Yeah.
from the perspective on anything other than I had the privilege a few years ago of spending, well, I constantly have this privilege of getting to watch teachers implement thinking classrooms. And an interesting pattern occurred that was certainly not based on anything I had said. And I think it was just a really naturally occurring pattern. And it was watching how teachers lapped the room. So they would give a task, and it was interesting to watch. And I'm not saying everyone does this, but a lot of teachers started to naturally do this. And this is not prescriptive. The first lap was going around making sure every group understood what the task was. The second lap was more concerned about flow and engagement. Right, so groups are starting to get through the first task now, we're extending. The second lap was about that as well. And it wasn't until like the fourth or fifth lap that they started to engage with students who were disengaged. So it was really interesting to watch the way teachers were clearly prioritizing the engaged students over the disengaged students. So, and from an analytic perspective, this kind of makes sense. If our goal is to get students in flow and keep them in flow, then that's where the focus is. But also it takes a lot less energy to keep a student in flow than to engage a disengaged student. So until, and what happens, and one of the things that Lam didn't mention here is that, and I'm willing, and it's a question for you. At the beginning, in thin slicing, the tasks are moving really fast. But then it gets to a point where every group is working on a question that is difficult for them. And everything slows down. Because now, not that the gap between the concepts has changed, but the speed at which you have to react is slowing down. And I think that's when teachers are starting to find the time to start to try to deal with some of the more difficult situations. Any thoughts on that, Lam?
Yeah, I mean, I guess over time, I've had to deal with it less and less. Is one thing I want to say first, right? Because like, you know, at school, I actually had the pleasure of teaching the same group of kids for 3 years in a row, like it's the exact same group. So I have less experience with those off-task behaviors. What you say makes sense, right? Like you pay attention to what's important, and you know, I don't know. That's all I have for that.
Like that one example, Peter, when we were in a class and the teacher, everybody came back to this phrase that she was chasing the learning. And that was so beautiful to see that she was attending and focusing on where the learning is happening. And that's really what mattered. And the little micro moves that you make when you're the teacher, it shows and communicates to the learners that that's what matters. It's a good topic to discuss, though. Maybe someone else has examples.
Is that better now? Can you hear me?
Yep.
Yeah, I changed computers. Sorry. So I'm pretty relaxed about the whole thing. Like, it's a long journey with the kids in front of you, and you know, for me, it takes week 4 or week 5 where all of a sudden I feel like everybody's kind of into it and like is in a groove, and it's just being persistent, like not giving up on it. And it's like every single day. And I like Peter's idea, what Peter was talking about like, yeah, your first trip around the room is just to make sure everyone knows what's going on. You know, then to see what they're doing, like, are they on task, or like, are they on task, but are they heading down a path that's kind of okay, trying to sneak into what their thinking is, and then maybe go and look at some of the groups that are like gone sideways. Like, I'm not going to spend my energy on them early in the class. Well, there's other things that I need to worry about. So, you know, I like that idea, but I would also comment that kind of happens throughout the course too. Like, you know, I don't know when it is, like week 4, week 5, week 6, it depends on the course, but every semester it's like all of a sudden, you know, within 5 minutes, everybody's up working, and I'm like, okay, here we go. Like, we're here, we've arrived, and the next 2 months are going to be great. But those first 5 or 6 weeks are, you know, you have to be persistent. It's tough work. It's tough to get everybody on board for sure, but I think it's doable.
And I'm going to put it out there to the rest of the people here, especially those who are practiced in this. I mean, if it's a tough sell, right? This dynamic of a thinking classroom, students being up and doing the work, that's not their norm. So this is a shift for every student the first day. But if you get those students who do commit early, I mean, how much do they become the ambassadors of this culture? Because you're randomizing the groups every day, so it's not like it's being entrenched in these little cohorts, but rather it keeps constantly being thrown out and permeated throughout the group. I think Al just mentioned it could take up to 6 weeks, which might have a couple administrators raise their eyebrows, but I find that to be the case. Eventually, they're policing their own. Not in every case. I don't think there's ever going to be a silver bullet, but that's been my experience when I've had success with it. And I'm wondering if others have seen that too. I think that's one of the key values of visually randomizing the groups.
And then there's
It takes
yeah,
a long time as well. I mean, and for some classes, it never happens. I get them up and about and doing tasks, and not the thin slicing. I'm new to that. And I just do it occasionally, but even it's kind of scaffolded. But like I think it was Alex I mentioned, 6 weeks upwards, and then even then I have to constantly go back and reinforce. And then I have there's a lot of student flux, so new students coming in, students leaving, so the dynamics change and personalities, and you know, just things that are going on in their lives, they're bringing into the classroom. So having to kind of constantly reformulate and that constantly. So I'm full agreement with the 6 weeks plus. So that's, I find that's normal, but I can tell you, it pays off. And it's a hard sell for my colleagues because they see, oh, like, you know, oh, I have to get through all this material. I have like 500 standards to get through. But it kind of starts slow, but at the end, it's like they're doing it. They're taking control, and that's, you're like, kind of like, oh yeah, you got it.
And let's not forget the year-over-year effect as well. So Al, like, word's out at Glebe that if you get Al over with, that's what it's going to be like, right? So unless they're brand new to the school, there is this sort of knowledge as they're coming in, and expectations. Same with you, Lam. You've been there a number of years now. And Mike Pruner told this story when he was presenting about how he had done implemented thinking classrooms from several years, and then he switched schools. And he thought he could just pick up and start exactly where he was the next year because he was so well versed in it, but he had to rebuild that reputation and that culture within the school for him. And now it's fine. People know what to expect when they get him. And there's that year-over-year effect that happens as well, I think.
Yeah, I had
Yeah.
a graduating student say that my legacy is the playing cards, right? It's funny that it's what they identify, not the markers, not the whiteboards. When they see, like, I have the cards in my pocket everywhere, just so, yeah, it's what they attach.
I think one of my biggest pet peeves is, and maybe it's why I'm so vocal about sharing the thinking classroom in general, is I'm so sick of me competing with 7 other teachers that these students have, where it's like, oh, it's like now we're Dunn's room, now we got to do some thinking. It's like we can get away with a lot less in these other classes, but it drives me insane. So I can be a little bit, I think, overbearing, but I'm trying to pave my own road here with other people's students.
So Will, it looks like we're a bit over time. Do you know if the chat is saved as well? I don't know, like it's a lot, so I don't know.
Yep, so
what
all the
happens.
videos, yep, all the video is saved, the chat gets saved, and then when resources, links, and so forth get mentioned in the chat, I put those in a separate document, and then I drop the chat box and the link doc with the video when I archive it on the website, which I think I linked to in there, and you can always message me if you want the link to the archived stuff. I think we are probably reaching the end here. I'm gonna, before I forget, 1 week from tonight, this one's a little bit sooner than the rest. 1 week from tonight is the next practice sharing session. So if you're on the list, you'll get that email. That's just because the timing worked out that way. And I think Garrett Schneider's in here. He's gonna be one of the folks who are doing that. And I forget who some of the others are. So put that in your calendar, same time. And then there'll be another one in first or second week of February, likely, with Laura Wheeler and Karen Hepburn and maybe some others who are going to share some of their mindful note forms and what their teacher moves are with respect to those mindful notes and what the student expectations are with respect to those mindful notes. So just ways that element is addressed. Next week's topic is kind of like think of like a starter kit. The first 3 elements are the first elements you cycle into a thinking classroom that first year. So for those people who are looking to revisit those topics in their own practice, or who have yet to implement it but want some ideas or actual concrete practices that they can bring into their classroom, you'll see that a week from tonight. And then finally, I just want to say thanks to Lam for leading tonight's conversations and sharing his own practices. It was great.
My pleasure. Thanks for the invite.